Hello, welcome everyone. In this question, it says 82 kilogram man dropped from rest on a diving board 3 meters above the surface of water, and it come to rest 0.55 seconds after reaching the water. What force does the water exert on him? So here it's asking reaction force. And if we have a diving board like this, for example, and this is the level of the water, and this is the height of the diving board, which is 3 meters, and this is the guy here, and he jumps from here to down. So here in this question we have two cases, two parts, whatever else. The one part is in the air, the one part in water, because in the question it says the guy dropped from rest. So here initial velocity is 0, and we have to calculate final velocity of the guy in the air, and that final velocity of the guy in the air, it will be initial velocity of the guy in the water, and final velocity of the guy in the water will be 0 again. And we can calculate this final velocity by using free fall formulas. So V final square equal V initial square plus 2gy. And initial velocity in the air, it is 0. So V final will be equal, if we take the root of the both sides, 2gy. So V final, if we substitute the numbers, 2 times 9.8 times 3 under root, so it will be positive or negative 7.7 meter per second, because it is square root. How we decide the velocity? It is in downward. Downward means negative y direction, so result must be negative 7.7 meter per second. And then it's asking what is the force exerted on him. So here its velocity will be 7.7 meter per second. For the water final, for the air final, and for the water initial, it will be again same, negative 7.7 meter per second. So F times delta T equal delta P. So as a result, it's asking F, so F equal delta P over delta T. So F will be delta P means M times V final minus M times V initial over delta T. And final velocity inside the water, it is 0. 0 minus mass of the guy, 82, times initial velocity of it, negative 7.7, over time is given 0.55 seconds. So it will be, force will be 1.1 times 10 to 3 Newton, and the direction will be up. Thanks for listening.